Okay, today we're going to be talking about molecular mass and how to use it to convert between grams and moles. And also we'll do a little bit with percent composition. So let's start with molecular mass. This is Unit 8, and these are some sample problems that we did in class. And the first one we'll do is right here, ammonium sulfide. Okay, the first thing we want to do is have a periodic table handy so that you know the molecular mass of each one of these elements. So since this whole compound is not on the periodic table, you're going to want to use each part of it, and then add them up and find the total. So if you look on the periodic table, nitrogen is 14.007 grams in a mole, but there are 2 nitrogens in this compound. This 2 outside the parentheses needs to be multiplied. So when you use a calculator, you get 28.014. Hydrogen is going to contribute 1.008 for each hydrogen. But here you have 4 hydrogens in the molecule, but there's 2 sets of the ammonium ions. So 4 times 2 is 8, and that results in 8.064. Then sulfur, way down here, if you look on the periodic table, that has a mass of 32.066, and since there's only one of them in the compound, you just can either leave it by itself or multiply by 1. Now all you do is simply just take the sum of these 3, and when you put that all together in a calculator, you get that the molecular mass of ammonium sulfide is 68.144 grams per mole. Now be careful about your significant figures. There are 5 sig figs here. 2 is an infinite number of sig figs because there's exactly 2 nitrogens. You're counting the number of nitrogens. There can't be almost 2 or a little more than 2. They're exact. So 5 or infinity results in 5. 4 infinity, 4 sig figs, and so forth. When you add them, you're not looking at sig figs, you're looking at the number of decimal places, or places after the decimal point. There's 3 here, 3 here, 3 here, so my answer has 3. Pretty simple, so let's try that. The word calcium nitrate means that it's an ionic compound. You have calcium, and if you look on the periodic table, it has an oxidation number of +2, which means it wants to get rid of 2 electrons in order to be more stable like a noble gas. Nitrate is not on the periodic table, but if you look on the back, it's on the polyatomic chart, and it has a -1 charge. When you look at this and put them together, you're going to crisscross and drop, and your resulting compound will have 1 calcium and 2 nitrate ions. The reason for that is because each nitrate is going to take an electron, but calcium has to give away 2 electrons. So it needs 2 nitrates in order for each nitrate to take 1 electron, which results in this bonding. Now we're just going to add it up like before. Looking at the periodic table, you have 3 elements in this compound: calcium, nitrogen, and oxygen. Calcium has an atomic mass of 40.078, and there's only one of them in the compound. Nitrogen has a mass of 14.007, but there are 2 nitrogens in this compound, so you have to double it. And then oxygen has an atomic mass of 15.999, and there are 3 in this compound, or in this ion, but there's 2 sets of them, so 2 times 3 makes 6. Okay, notice that I maintain my significant figures. 5 here, there's an infinite number, and the 1 because there's exactly 1, which is 1.00 infinity. So we use 5, 5 infinity, 5, and so forth. When we add them all up, we're looking at decimal places. There's 3, 3, and 3. So when you use your calculator, you get 164.086 grams per mole, which means if you had 1 mole of calcium nitrate, it would have a mass of 164.086 grams. All right. In this problem, they give you moles and they want to know how many grams. Okay, and they give you the formula. So the first thing we need to do is figure out how many grams would be in 1 mole. You don't have 1 mole, but we can start with that. Okay, so what we'll do is we'll look at hydrogen, and hydrogen has an atomic mass of 1.008. You need to double it because there's 2 in the compound. Sulfur has a mass of 32.066. This is coming right off the periodic table. Okay, and I maintain 4 sig figs and 4 sig figs. When I add them, I get to have 3 decimal places. So the sum of this is, let me move this out of the way. The sum of this becomes 34.082 grams in 1 mole. That's all we did. We just added up how many grams were in each mole of hydrogen sulfide. But we don't have a whole mole. We have 0.2 moles. So let's see what that would be. You always start with what you're given. So 0.200 moles. Okay. And we're trying to get to grams. We want to get rid of this mole, so we're going to keep the moles on the bottom in the denominator. Okay. Now we can cancel these units out. We're not canceling the whole number, just the units. Remember that our numerators are always multiplied, our denominators are divided, and when you type in your calculator 0.200 times this number, you're going to get 6.8164 grams, and that's our units, but that's not the right significant figures. In this spot, there are 3 significant digits. Okay, here you have 5, so the least from 3 and 5 is just to have 3 significant digits. So here's 1, 2, 3. This 1 is going to be rounded up because of the 6, so our resulting answer will be 6.82 grams, and you're done. So in this case, we have grams and we want to find moles. So we can go back and find our conversion factor again. Again, this case is water. So hydrogen has a molar mass of 1.008. There's 2 of them. Oxygen, 15.999. There's 1 of those. Okay. When you add those up, you get 18.015 grams per mole. Okay, start with what you're given. You have 2.00 grams. Now be careful here. You're going to be tempted to just put this in right like it is, but if you did that, you would have grams and grams in the numerator, which won't really help you. So you have to flip your conversion so that grams are on the bottom and then your moles are on top. Now your grams will cancel and you're left with moles in the numerator. Remember, numerators are multiplied, denominators are divided. So in your calculator, you type in 2.00 divided by 18.015. The resulting answer is 0.111 moles. Again, moles is your units. Okay. I use 3 significant digits here because if you look, this has 3 sig figs. The bottom has 5, so your answer can only have 3. Okay. Here it asks for how many moles of ammonia. Okay. Ammonia is not on the periodic table, nor is it on your chart on the back. You just have to know. You do see ammonium on the back of your polyatomic chart, and that gives you a clue, but ammonia has a formula of NH3. It's just something you're going to have to know. All right, the molar mass of ammonia has 1 nitrogen and it has 3 hydrogens. So nitrogen is 14.007. Hydrogen is 1.008 times 3. Okay, when you add all of them up, you get 17.031 grams per mole. Okay, that's the molar mass. Okay, now down here you're going to look at what you're starting with. You're looking for moles, but you have molecules. Well, gosh, that molar mass didn't help you at all. So you might remember Avogadro's number is 6.02 times 10 to the 23rd of anything, okay, in a mole. So it could be grains of salt, atoms, molecules, ions, iPads, toenails. It doesn't really matter. 6.02 times 10 to the 23rd of anything at all in the whole world is in a mole. So it's sort of like a dozen. It's an actual measuring tool. So there we go. All right, so let's go back. We have 1.20 times 10 to the 25th molecules. Okay. And we're trying to figure out how many moles that would be. Well, grams don't help us, but this thing could help us because molecules are things. So if you take Avogadro's number, okay, molecules are not the same as moles. They look similar, but they're not the same. Okay, so then you cancel, and voila, you have moles. So when you type that into your calculator, you get some funny things. If you have scientific notation in your calculator, you're going to get something like this, 1.99 something times 10 to the first. Okay, but that's kind of a silly way to write things. So let's go ahead and multiply it by 10 because 10 to the 1 is the same as 10. And go ahead and make it look a little more normal. So it's 19.9 moles. And I have 3 significant digits in my answer because there's 3 here and 3. Copper is Cu on the periodic table. There's nothing more to it. You don't have to double it or add it with anything. And it has a molar mass, if you look on the periodic table, of 63.546 grams per mole. Okay? So you didn't have to calculate anything. It was just right off the periodic table. It's nice to get a break sometimes. Okay, take your starting information, 3.2 times 10 to the 22nd atoms. And what are we looking for? We're trying to find, you can't see the problem, but it asks for grams. So we're looking for grams. That's our goal. Okay, now how can we get from atoms to grams? Well, there's not anything that gets us from atoms to grams, but we can go part of the way by going atoms to moles using Avogadro's number. Because it says 6.02 times 10 to the 23rd things, atoms are things, in a mole. That helps us a little bit. So we've gotten ourselves part of the way there. Then we can go from moles to grams using our molar mass. Okay. We want to keep in mind that we keep our units where they can cancel out. Don't just randomly put fractions in there or conversion factors. People want to be lazy and leave their units out, but then when that happens, they start making all kinds of mistakes. Numerators are multiplied, so you're multiplying 3.2 times 10 to the 22nd times the 63.546. Multiply your numerators, hit the enter button, divide by your denominators. It's the simplest way to get the right answer. Okay, so you're going to get an answer that looks something like this, 3.37786, and then a bunch of other calculator vomit, times 10 to the 0. Well, that just looks weird. Nobody uses times 10 to the 0. Anything to the 0 power is equal to 1. So you don't need to worry about multiplying it by 1. That's just kind of silly. So we'll just rewrite it, 3.38 grams, because now we're using our sig figs, and we're boxing it in, and you're good to go.